So what is the question you have? Which integration?
It was 1/2 to the power of n.
Yeah. And what do you have to do with that? And 1/2 to the n?
Yeah.
What is your question?
It is question 3 from homework 9.3.
Just one second. Section 9.3. Oh, okay. So the sum of this infinite series. So this is a geometric series. So a geometric series sometimes is written like this: a r to the n minus 1, n goes from 1 to infinity, and this converges to a over 1 minus r if the absolute value of r is less than 1. So this is the most fundamental fact about series. This geometric series converges. If a is equal to 1, this is just summation n goes from 1 to infinity, r to the n minus 1 equals 1 over 1 minus r. And you can also write this as, well, that's what it is. So let's look at your series. It's not, so you could say, so we have summation 1/2 to the n goes from 1 to infinity. This is really summation n goes from 1 to infinity. 1/2 to the n is just 1/2 to the power n. So we're just looking at powers of n. If I sort of write 1/2 to the n as a half times 1/2 to the n minus 1, then this is exactly in this form with a equal to a half and r equal to a half. And r is less than 1. So this converges to a over 1 minus r. If you multiply by 2, you get 1. So the sum of this, so this geometric series converges to 1. That's the answer.
How did you get to the summation from 1 to infinity 1/2 times a half n to the n minus 1?
Well, I mean, you know, in general that, you know, r to the k times r to the l is r to the k plus l, right? I mean, that's just rules of exponents. So r to the 1 times r to the n minus 1 is r to the n. So all I'm saying is that r to the n is r times r to the n minus 1. That's all.
Oh, okay, I see.
I mean, that. A simpler way to write down the geometric series is if you have summation r to the n, r goes from 0 to infinity. This is equal to 1 over 1 minus r if r is less than 1 in absolute value. But either in this form or in this form, you play with these, you do a little bit of algebraic manipulation, and you always will get the sum of the geometric series.
I don't have any more questions.
Okay, that's fine.